Hi everyone, Lior is here with another Jumpstart Lightning episode. Today I have Anthony to talk to me about SQL and Kubernetes and why it's the foundation for Azure Arc-enabled data services. Stay tuned, let's do this. Hey everyone, we are in another Jumpstart Lightning episode. Today I have Anthony. Anthony, how are you doing, sir?
Good, sir. How are you doing?
I'm doing great. I was looking forward to talking to you. We've been, like all my guests, I've been talking to you before that, and I was excited about the opportunity here. But before we get started, Anthony, tell the viewers who you are. What is it that you do?
Hey there, everyone. I am Anthony Docentino. I'm a principal field solution architect at Pure Storage, where I focus on SQL Server and Kubernetes, and Azure Arc-enabled data services. Prior to that, I spent 10 years as an independent consultant focusing on high-end database systems. I've been a data platform MVP for the last 5 years and an active member of the SQL Server community as both an organizer and a speaker.
You know, Anthony, what I like about this show and the way for me to talk to people like yourself is that really a lot of people are coming from different backgrounds, right? And obviously you have a good laundry list of experience and all the other guests as well. So it gives me an opportunity to get good perspective on things and how people are actually approaching this entire hybrid technology space and all that jazz. So today, Anthony, what we want to talk about with the Jumpstart viewers is specifically SQL and Kubernetes and why it's really the foundation for Azure Arc-enabled data services, which is obviously a big thing. So we're going to share some cool stuff with the audience today. But I wanted to ask you, why SQL and Kubernetes? Why you care about that much to the point that you wrote a book about that? We'll talk about that later on as well. But why? What's the use cases here?
So maybe I'll tell a story. A couple of years ago, I was at a Microsoft event and I saw Kubernetes for the first time. And I saw the speaker able to deploy systems in code consistently over and over and over again in an automated way, test it. And that kind of I was like, that's going to be a thing. Because especially as a data professional, I was used to building systems from scratch, right? Logging in, back in the day, like putting a DVD in or putting the ISO in and building that system. And that's error prone. We all have checklists and things like that, but we're humans and we don't quite follow the checklist to a T.
Right.
And data professionals have been doing that for years, basically custom building every single system. And then we've kind of graduated to PowerShell and automation and things like that to help us solve those repetitive technique problems. But really with Kubernetes, it kind of flips the switch from those imperative techniques of configuring a system to a declarative technique of configuring a system or deploying a system even. And I can just say, you know what? I want a SQL server up and running, attach some storage to it and give it this much RAM and make sure it kind of stays over there next to those application servers for performance. And we can write code that just describes that to happen. And I can run that anywhere, whether it's on-prem, in the cloud, in different clouds and things like that. And that story, when I saw that, was something that really, really piqued my interest. And I really felt strongly to start evangelizing in a data community that this is going to be the way that we're building systems in the future. And this is, maybe 2 or 3 years ago. And then here we are today, right? We're talking about a product that's GA that does that thing. I can deploy entire data platforms inside of Kubernetes and underneath the umbrella of Azure Arc-enabled data services like that, consistently test it and secure every single time, which is super fabulous.
It's really that abstraction layer, Anthony, right? That we're talking about. It's really the fact that we're no longer talking about, hey, deploy a VM and they deploy, or a bare metal, or then deploy the actual solution and then connect the solution to the actual application. So you have the, the back end, the middle tier, the front end, like all that stuff. And it's really about that ease of deployment. But I wanted to ask you a question. Don't you find that sometimes when you're talking to people that are more kind of data-oriented, DBAs and whatnot, that don't you find that weird that now things are much easier for you maybe to understand in terms of the abstraction, but for them, it's still getting used to this world of what SQL and Kubernetes, and that happens like in a, just in a YAML manifest fashion, and you're just deploying that, and that's it. Like, I mean, talk to me about these type of conversations. I mean, I care about that.
So the biggest idea I like to pitch to folks is nobody really cares if SQL Server's online. What they care about is, can they get to the data, right? Can I get to the database that actually has the stuff that empowers my business? And that's what Kubernetes does, or any container-based platform, is I have some data over here, and it just puts a compute thing in front of that, and it just happens to be a SQL Server container, right? And I'm able to access the databases and do the things that I need to do. And so that idea of decoupling the configuration of the system, right, the code that describes what I want, and the actual state, I think, is a way that I'm able to drive that home in the community, because really it's the data that matters. And how do I get access to that data? Just make sure there's a SQL Server there, right?
Yeah. You know, I think that, and obviously you know that as much as I do, that Kubernetes, for some people, it's super scary, and we all understand why. Kubernetes is complicated. Let's just, it is what it is. And as part of that being complicated for some people, and once you get used to it, that, the daemon is not that bad.
Right.
You and I, we've been having conversations about how do you approach the resource management when it comes to SQL specifically on Kubernetes. And there is a big difference between how do you approach that when you have a SQL, like a standard SQL instance deploy on premises, or even, on an instance inside on the cloud. And how does that look like in a Kubernetes world? So you want to talk to me about this? Like, let's share with the audience what are your thoughts that you have around this type of stuff?
So when we're working with container-based deployments of SQL Server, it's not unlike multi-instance Windows-based deployments. And one of the things that we had to do when we were working with the multiple instances of SQL Server running on maybe a single virtual machine or a single physical machine is we had to be really careful about resource management and maybe putting some boundaries around the resources that SQL Server has access to. And we want to show you today is how we can leverage limits inside of containers to do that same thing, but inside of the Kubernetes space. So if I have multiple containers of SQL Server running on a platform, that I can kind of put some boundaries around them or limits to control the access of resources. So basically, we don't have that noisy neighbor problem that you might have in kind of a shared infrastructure. And the key idea here is, well, this is the core of Azure Arc-enabled data services. In the end, there is a container running SQL Server that's going to be up and running. And we want to be able to, you can use these same techniques I'm going to show you today inside of Azure Arc-enabled data services. But what I am going to show you today is the majority of these demos I'm going to do in Docker on my laptop, but it's the same exact concept behind the scenes. And I will end it with looking at a SQL Server managed instance running in Azure Arc-enabled data services to show you that point. But in the end, resource management is your responsibility, right? The person that is deploying the system, and you have to do that math or that calculus to figure out where you want to run your workload. And so in the graphic here on the right, maybe I have 3 SQL Server containers up and running. They're all attached to some storage and they're all accessible via unique ports. But then again, it's up to me to make sure that I'm sharing the resources of the operating system in an appropriate way. And what are the core resources that an operating system provides, right? Access to the hardware, CPU, disk, RAM, network, and things like that. And so this is the idea, is if we have multiple instances running on the same host, that ball is in our court to manage the resource control. And so Docker...
Anthony, I remember conversations that I had in the past when I was still in the VMware space, and it kind of, this is a blast from the past here, but I remember conversations that I had when I was in the VMware space around resource management and resource pools and reservations and stuff like that. But that was on the VM level, right? And the VM is not aware to the fact that it has, a SQL instance or something else deployed. And I think that level of abstraction, what we're talking about here, is really where the rubber meets the road when it comes to resource allocation for the actual data layer that you need to get to, right? Like we talked about, you want to get to that data. That's really what you're talking about. So I find it very interesting, the journey. Like this is like a walk on memory lane, right? The journey that we went from the old bare metal world to the VMware stuff, and then coming, fast forward into this type of technology. So super interesting stuff.
One of the analogies I make is exactly what you described. So people ask me about, how do I plan for this? How do I provide enough resources? I'm like, the idea, the resource planning is not unlike building a VMware cluster. I want to have enough resources to run my workload, right? I'm going to know what that is because, a SQL Server, consumes this much memory. It's going to use this much disk and it's going to use this much CPU. And I want to make sure I have enough of that in my cluster and a little bit more, right? Because I want to be able to tolerate a node failure and not have a degradation of service. And so that those same concepts that you were describing really do apply in this scenario.
So I know that you have a cool demo. Let's
Cool.
get into it.
All right, so let's wrap up this slide real quick. One of the big things is, regardless of how you're doing this, it's going to be run by a thing called control groups. Again, like I said, we're going to focus on Docker today, but this applies to pretty much any container runtime. And so when we flip over into the demo, we'll see that we can assert limits on things like CPU, memory, block IO, and also the number of process IDs on a system. So let's go ahead and jump right into the demo. And so here I have VS Code up and running, and I'm going to start up a couple containers. I'm going to show you how SQL Server sees the underlying hardware. Then I'm going to create a container with some limits, kind of constraining the resource that it has access to, and then show you again how SQL Server sees that underlying hardware with a limit in place. And so let's not worry so much about the code here, but what I'm doing here is I'm just starting up a SQL Server container on 2019 on CU9. And so that's a SQL Server up and running on my laptop. Now I'm going to run a DMV query that's going to ask SQL Server, the instance that we just stood up together, to tell me what it sees from the underlying hardware. So this particular virtual machine that I'm running this container on has 4 vCPUs and 16 gigs of RAM. And you might be thinking, well, why do I only see 12 gigs of RAM? Because if I do a free -m, there's 16 gigs of RAM in the server, right? The machine that I'm running this workload on. Well, SQL Server on Linux is at the core of the SQL Server container, right? So it's literally a Linux process running SQL Server. And due to the architecture of SQL Server on Linux, by default, you are only going to see 80% of the physical memory available in the system. So that's where we go from 16 to 12. That's a configurable attribute of when we start up the container, but I wanted to show you the default configuration there. So no limits in place. I see all 4 cores and conceivably the amount of RAM that's available in the system, but in this case, only 80% of that. So moving forward, let's start up another container. This time I have 2 parameters. I'm going to limit this container's access to 4 gigabytes of RAM and 1 core, right? 1 CPU. The same exact code as before with 2 additional parameters and also the correct parameters to make it a unique instance. And so now I'm running, 2 separate SQL Server containers on unique ports on the system. So I can access these over the network as independent SQL Server instances. So let's access that second instance that I just stood up with the limits. And remember, I limited it to access to 1 CPU and to 4 gigabytes of RAM. But what do you see that's unique about the output here?
It's the limit.
Right. So I see, I said, hey, you can only have access to 1 CPU, but it says I have 4. Why is that? Right. And then now, so 4 gigs of RAM, 80% of that, it's like 3 gigs and change, integer math, right? I didn't want to have a bunch of decimals running across the screen. So when we set a memory limit, that's an actual limit to a range of memory for the container to access. And so in this case, I said, you know what? You can only have access to 4 gigs of RAM. It does. SQL Server on Linux sees 80% of that. There's the 3 gigs, right? So that's the actual amount of memory that this system can access. But what's unique about deploying SQL Server on containers and using limits is the container will see all of the cores in the system. It's up to the operating system scheduler to assert that 1 core limit, right? So the scheduler is going to distribute that workload, but limit me to an aggregate of 1 core, right? And so that's unique inside of SQL Server because SQL Server does stuff like makes query plans based on the number of cores available in the system. And so we have to take that into account when we're building and designing our systems. We know, like when I'm allocating hardware, well, the scheduler is going to maintain access to all the cores. I need to have enough memory in the system to make sure that I have enough memory for all of the instances inside of my system, and that SQL Server is seeing them the correct way. So if I run Docker stats now, we're going to see Docker stats, a pretty cool utility that basically it's like top on a Linux system to iteratively get the resource allocation of the system. So that first container, right, using about 700 megs, and there you can see no limits. It has access to all of the memory. Even though SQL Server only saw 12, the actual container is still consuming 16. And then the server that we started up second, or excuse me, the container, after all these years, I still do that. The server that we started up second, right? The container that we started up second with a limit of 4 gigs only sees that much, right? And I think that's a key point I wanted to drive home here. So when you're looking at these resource allocations, just kind of understand how SQL Server sees it and then has access to that memory. And so let's flip the page here and look at an Azure Arc-enabled SQL managed instance. I've pre-deployed this managed instance on my system. You can see it's up and running. It's ready, right? Again, I deployed an entire SQL Server managed instance with that line of code, right? Not a lot of configuration, but we can go as far as we want with the parameters that are available to us. But I can, like that, I have access to a SQL Server managed instance. Again, that is a crazy, powerful technique that I think for people that build these kind of systems. Go ahead, sir.
And Anthony, a few things that I'm taking out of this. One, talking about Azure Arc-enabled data services, and for the viewers that are not familiar with, the entire way that this is being built, but the limits is actually super critical, because that's how we are also calculating the billing aspect of it, right? That's really kind of how we're doing. So the process is that we're defining the limit on the actual container instance, right? The data controller picks it up, reports back to the billing API for Azure Resource Manager, and that's really how the flow looks like. So I find it very interesting that this is how the sausage is being made, right, behind the scenes. So it's pretty cool. And the second thing is that when you're looking at the SQL command, like the AZ SQL MI for Arc command, and you are comparing that, if you're a data person, if you're comparing that to SQL managed instance on Azure, and how much time it takes to deploy SQL managed instance on Azure, and the fact that, sure, it has its own benefits and all that, but that's a different ballgame when it comes to the speed of deployment and the actual time for solution. That's really what the powerful message that comes around that. So yeah.
Yeah, I think if you saw me start and start those containers that we were working with earlier, that's seconds operation. Yeah, I have the container image local on my workstation. That makes that really quick. But even if I had to pull that image down, that's not that long of a time to wait. And similarly with the managed instance deployment, it's a couple of gigabytes for the container, which is titanic in the container space. But for a SQL server, that's not. That's a very small footprint to deploy the actual system.
Right.
You did touch on one point I wanted. Oh, sorry.
Yeah, go ahead, Anthony. Yeah.
I want to touch on one point. Limits, you talked about the criticality of limits and not having your bills run off. But if SQL Server has access to all of the memory in the system, right, by design, it will try to use all of the memory in the system to fill up its caches and its buffer pool. So if you don't put a limit on the memory of a managed instance or even a regular SQL Server container, it's going to use all of the memory that it needs to, that's available to it from the underlying operating system. And that can run away from a billing standpoint, but from a performance standpoint, there's no swap in Kubernetes. So if I get pressure from another process on the system, I could potentially wind up with a process getting terminated that might be my actual SQL Server deployment, which would be bad. So limits are critical from an availability standpoint.
That's resource management 101 when it comes to Kubernetes, right? To have that governance, to have that processes already in mind. This is why this needs to be part of a CI process that already have all these logic, CI and CD processes that has all these logics embedded to them. So I mean, I can definitely relate to that. So pretty cool demo. I mean, it's nice to see how the sausage is being made. So Anthony, kind of switching to a more of a personal note, or talking about what is it that you're doing these days. I know that you joined Pure Storage, and I also know that Pure Storage, obviously having that visibility to the things that we do with Azure Arc and the product group. I know that Pure Storage are working with us very closely. Can you talk to me about that? How's the experience going so far?
Man, so it's been 2 months, and it's the most fun I've had. Is it really called work when you work with friends? Let's be serious.
Yeah.
And so super smart people, friends that are kind of guiding me along the way. I've learned a bunch about the different products and a lot of the capabilities that I might have heard of, but now I've had the time to actually dig into and learn about stuff. And it's been a core focus of Pure to focus on things like Portworx, Kubernetes, stateful containers and things like that. And most recently, the team produced a Pure Validated Design, or a reference architecture for running Azure Arc-enabled data services on top of Tanzu, on top of Portworx. And so if you really want to dive into how you would do this on-prem, that design kind of describes what you need to configure and where. I mean, down to the actual configuration elements. It's a fantastic document put together by Chris.
I saw that document. I still didn't have a chance to look the entire thing. I mean, I'm aware of the document. I understand the value proposition of the document. Obviously, we're going to share it in the link down below.
Sure.
But Anthony, you took it to a place that you said, all right, I'm very passionate about this thing. And at the end of the day, you came up, alongside with your partner in crime, Ben Weissman. He was here on the show before that. So this is the book that you just released with Ben. So this is SQL on Kubernetes, super straightforward, right? And it's pretty thick. There is a good amount of pages in this bad boy. Talk to me for a second about the book and the experience around that, and working on this.
Sure. So the book is targeted towards the DBA, right? So if you're a data professional and you've never seen Kubernetes before, that's cool. And what you'll do in the book is you'll maybe create a couple of containers. You'll learn how to kind of decouple the state of the container from the actual runtime of the container. And then we dive straight in and learn how to build a cluster, learn how to do deployments, learn how to do storage, and then learn how to actually kind of culminating in deploying SQL Server on Kubernetes. And so that's the target audience. So if you're a data professional and don't have that background in either containers or systems or things like that, this is the book for you.
And this is, kind of goes hand in hand with the previous book that we shared when Ben was on the Jumpstart Lightning episode before you. So it's great to see that you guys are a partner in crime on this. And like we said, the Azure Arc-enabled data services, the foundation for that is really to understand that sausage making, right? You don't have to understand that as I would say, as someone that is targeted towards the Azure Arc-enabled data services space and the infrastructure, but it is important for you to know how the SQL and Kubernetes platform works and the solution works, because at the end of the day, we're all technologies and we need to understand how, the car is being built. Some of us want to know more. Some of us, just want to know how to drive the car, but I think it's still super valid. And alongside with your book, I know that you're also very active on Pluralsight, and you also have like a bunch of courses. I think like 1,000 courses or something like that.
Not quite. Since I've been a Pluralsight author, I've written 23 courses, which honestly, I have to pinch myself to the fact that even has for one, that I became a Pluralsight author, and two, that I've produced that much content. But I have a ton of content on Kubernetes, targeting the CKA, or Certified Kubernetes Administrator certification. So really kind of the systems person that wants to get in there and build the stuff. I have a bunch of content on Azure Compute, so containers, VMs, things like that, and also on PowerShell. I do want to touch on a point that you just made a second ago.
Impressive.
The analogy, the VMware analogy, kind of extends into what we were just discussing, in that some data professionals don't quite care about the infrastructure, and some data professionals do. Really, it kind of depends on your expertise and your interest and needs of your system. And so if you're the kind of person, a data professional, that wants to dive into kind of how the bits and the bytes kind of flow through your system, that's going to be that's the person that's going to learn about Kubernetes. But if you just want to deploy and consume data services, that's okay, right? That's a totally valid use case for the platform. But again, that's kind of the different personas, I guess you could say, that consume these kind of systems.
I can totally relate. I think that, like I said, that the walk in memory lane when it comes to the VMware stuff and how everything ties together to, this new modern way of doing things, right? I know that VMware are also very deep in the Kubernetes space with Tanzu and all that, but I think that this really ties everything together. The Azure Arc-enabled data services, specifically with SQL Managed Instance, and obviously with Postgres, there is a lot of innovation going on. There's a lot of innovation going on there. And when it comes to SQL and Kubernetes, like I said, kind of the fundamental building block. So, Anthony, to wrap things up, I mean, this has been a great Jumpstart Lightning episode. How can people reach out to you, where they can find you?
Sure. Probably the best and easiest way to get a hold of me is at my Twitter handle, which should be on the screen here. So @NoCentino. If you feel free to you can shoot me an email at anocentino@purestorage.com if you kind of want to talk about any of the ideas and concepts that we talked about today, or just hit me up on Twitter, DM, or just @ me, and I can be available to chat about this if you want to.
Awesome stuff, Anthony. So for the viewers, thank you so much for joining into another Jumpstart Lightning episode. We appreciate if you can subscribe so you can know when we have another awesome guest, and also give us a big like button so you will know, also, and the bell so you will know when we're releasing a new Jumpstart Lightning episode, when we're releasing a new demo to the Jumpstart channel. And until next time, thank you, Anthony. It's been a pleasure. And for the viewers, thank you so much for watching. See you next time. Bye, everyone.